Welcome to the Explainer. We often think of modern engineering as the absolute pinnacle of human achievement. We build higher, faster, and with materials that just feel invincible. But what happens when the Earth decides to, well, test that invincibility? Today, we're embarking on a really fascinating architectural autopsy to uncover a thousand-year-old secret of survival.
7.7. In January 2001, a devastating earthquake measuring 7.7 on the Richter scale struck the Kutch region of Gujarat, India. The stakes during an event like this are entirely life or death. The sheer kinetic energy unleashed is literally unimaginable. It caused massive infrastructure collapse, completely leveling modern buildings that were supposedly built with the latest, strongest materials. Entire cities crumbled. But amidst all of this tragic, overwhelming destruction, something truly incredible happened.
So, what does this all mean? Well, it brings us to the core mystery of our explainer today. How on earth did the Modhera Sun Temple, an 11th century structure built without a single drop of cement or modern steel rebar, how did it survive the exact same seismic event that completely flattened modern concrete structures? It wasn't magic, and it definitely wasn't just luck. It was an incredibly sophisticated understanding of structural intelligence and earthquake resilience developed centuries before modern seismic science even existed.
Okay, part 1, Foundations, Ancient Shock Absorbers. Let's dive into this and start deconstructing things from the ground up.
To understand how a building survives an earthquake, we really have to start at the very bottom. Think about how we build today. We pour these massive, rigid concrete foundations, right? We want our buildings locked tight into the earth. But when the ground shakes violently, rigid concrete can just snap under the immense shear stress. Ancient Indian architects, known as Chhatrapatis, they took the exact opposite approach. Instead of fighting the earth, they used a technique we'd now call mechanically stabilized earth. They dug deep and laid down incredibly thick, cushioning layers of river sand and gravel right beneath the stone plinths. Sand, with its granular flexibility, actually acts as a natural shock absorber. It diffuses the kinetic energy of tremors, acting like a giant cushion so the violent shaking doesn't transfer directly into the rigid stone above. Once that giant sand bed is laid, they built upon it. The Modhera Sun Temple sits on a massive, elevated sandstone platform. In the ancient texts, this is called the Adhisthana. And it's not just there for aesthetics or to look grand. This broad, multi-layered base acts as an absolutely critical seismic buffer. By spreading the footprint of the temple incredibly wide, it disperses the vertical load of the entire structure over a massive area. This anchors it, while simultaneously reducing the shear stress from any sudden ground movement.
All right, moving upward. Part 2, Breathing Walls, Interlocking Masonry.
So, we have a shock-absorbing foundation. Now, let's guide our architectural autopsy up to the walls. How exactly does a heavy stone structure handle the violent lateral shaking of a 7.7 magnitude earthquake without just vibrating into pieces? Well, the secret is what we call dry masonry. There is absolutely no rigid cement or mortar holding these ancient walls together. Think about it. If you use rigid cement and the earth shakes, the joints crack and the whole wall fails. Instead, these builders used precision-cut stones locked together using advanced mechanical methods like mortise and tenon joints. By building without cement, the entire structure is allowed to breathe. It flexes. When the seismic waves hit, these joints allow for tiny micro-adjustments, accommodating those subtle shifts rather than stubbornly resisting them until they break. The intricate precision of these mortarless joints is honestly mind-blowing. The stones are literally pegged and slotted into one another, kind of like a massive 3D puzzle. Because of this, when an earthquake happens, these interlocking walls actually dance with the seismic waves. They rattle, they shift slightly, they absorb the kinetic energy through movement, and then gravity just pulls them right back into their locked equilibrium. It's a completely dynamic defense, rather than a static one.
Part 3, the Stellate Geometry Defense.
Now, we've covered the foundation and the joinery, but what's really interesting is that the stunning beauty of these structures actually hides a sophisticated geometric defense mechanism. Viewed from the top down, Hoysala temples further south, like the Chenikashava and Ishwara temples built in the 13th century, utilize a rotating circular plan. Instead of a basic square or rectangle, these architects created an incredibly complex 16-pointed star-shaped geometry, which is known as a stellate plan. You've got these multifaceted exterior walls and meticulously lathe-turned interior pillars. But, why a star?
It's all about dispersing lateral forces. If an earthquake hits a massive, flat, uninterrupted wall, the seismic energy hits it all at once. It finds the weakest point and just concentrates the stress there until the wall blows out. But by creating these highly recessed, broken, and zigzagging wall plans, ancient engineers forced the seismic waves to break up. The energy is dispersed across dozens of different angles and projections. That prevents the stress from ever concentrating on any single structural plane. It's totally ingenious.
Which brings us to part 4, Meru Prasada, tuned mass dampers.
Our autopsy takes us now to the very top of the temple, the towering, heavily carved spire known as the Shikara in the north or Vimana in the south. Now, you'd probably think putting a massive stone tower on top of a building in an earthquake zone is a terrible idea, right? But in the ancient Vastu Shastra texts, there's a core engineering strategy called the Meru Prasadhan model. Cosmologically, this represents the mythic Mount Meru, the center of the universe. But structurally, it is a brilliant feat of physics. It treats the temple tower as a central vertical axis where all mass and load are perfectly symmetrically distributed. This creates a tapered pyramidal geometry that naturally facilitates downward load transfer and almost entirely eliminates lateral thrust. The structural profile here is key. The base is incredibly wide and heavy, often built with super dense granite or sandstone. And as the tower rises, the mass gradually tapers and diminishes inward. This vertical massing creates an exceptionally low center of gravity. In engineering terms, this acts as an ancient tuned mass damper. It completely prevents the towering structure from becoming top-heavy and just toppling right over, during the wild horizontal whipping motions of a major tremor. So, let's step back and see how this all builds into a holistic defense system. Imagine a massive seismic wave hitting the Modhera Sun Temple right now. Step 1. The kinetic energy travels through the ground but hits that thick river sandbed, which instantly diffuses a huge chunk of that violent force. Step 2. Whatever energy makes it past the sand hits the massive wide plinth, dispersing it outward. Step 3. The lateral shaking reaches the walls, but because they have those dry masonry mortise and tenon joints, the stones flex, rattle, and breathe instead of cracking. And finally, step 4. The shaking reaches the heavy, tapered tower, but that low center of gravity acts as a mass damper, keeping the whole building rooted firmly in place. All right, part 5, modern tech in ancient stone. Let's wrap this up.
So, the crucial point here, the real culminating reveal of our autopsy, is what happens when modern structural engineers map these ancient concepts using 3D laser scanning and finite element analysis. They find something absolutely astonishing. Modern science is literally just now catching up to the wisdom of 11th century builders. Look at the direct mapping. What they achieved with sand and gravel cushioning, we now do with high-tech elastomeric base isolators. Their tapered towers with heavy bases, that is exactly how we use tuned mass dampers in modern skyscrapers like the Burj Khalifa. Their segmented independent temple halls act exactly like our modern compartmentalized structural grids. And those interlocking mortise and tenon stones, they serve the exact same function as our modern expansion joints.
And that leaves us with a truly fascinating question to ponder. We've seen the evidence, we've done the autopsy. These ancient builders understood balance, flexibility, and distributed strength so deeply that their stone monuments can quite literally shrug off 7.7 magnitude earthquakes. So I leave you with this thought. If 11th century builders achieved seismic immortality without steel or concrete, what are our modern cities doing wrong? Thank you so much for joining me on this deep dive in The Explainer. Keep questioning, keep learning, and I'll catch you on the next one.